Welcome back, Calculus. In this lesson, we're going to talk about evaluating limits analytically. So I'm going to do one quick example from the intro notes, and then I'm going to go to the analyzing limits analytically notes. So just this quick example, there's situations where we want to evaluate a limit, and we're going to do it without looking at a graph, looking at a table. We're going to do this algebraically. Anytime you're evaluating a limit, the first thing I recommend doing is trying to plug in the limit and see if we can actually get an output. But if you plug in 4, 4 minus 4 becomes 0. And on the bottom, we get 16 minus 12 minus 4, which also gives us 0. So that 0, 0 case is an indeterminate form. So when you get an indeterminate form, the question is, what do we do now to evaluate the limit? And the strategy is we're going to have 3 different strategies today, and one of them is just factoring. And the goal in every situation is to get something to cancel out. So it's kind of like when we worked with rational functions. We found out where the holes were. If there's a hole at a point, the limit will exist, and if there's an asymptote there, the limit won't exist. But the 0, 0 case means we can't determine what's going on yet in terms of the limit. We need to do a little bit more work, and strategy 1 is factor and cancel. So if I were to factor this function, x minus 4 over x squared minus 3x minus 4, then this becomes the limit of x over 4 divided by, so when you factor this out, we're going to get x minus 4, x plus 1, right? Negative 4 times 1 is negative 4, and negative 4 plus 1 is negative 3. And recognize that these x minus 4s divide out. When that happens, now it's just a limit as x approaches 4 of 1 over x plus 1. And now that those x minus 4s cancel out, now we can actually plug in this value 4 into the function. And when we do that, it's going to be 1 over 4 plus 1, which becomes 1/5. So the limit of this function as x approaches 4 is 1/5. So at 4, it doesn't exist. However, the function's approaching the value 1/5. So I don't know what that function looks like, but I know that as x approaches 4, the output is getting 1/5 is like 0.2. So the function is getting really, really close to this point here. And then at that point, we have a hole. So that's one strategy for evaluating limits analytically. And we're going to do another example like that right here. So if you're in OneNote on your computer, just go to the class notes, and you can copy and paste this so that you don't have to write it down. If you're in your notebook, you can pause the video just to give yourself an opportunity to write it down. But this example right here, you can try yourself before listening to the rest of the video. But I'm going to do it now. If you didn't pause, you can just pay attention. Here we have the limit as x approaches 2 of x squared minus 4 over x cubed plus 3x minus 10. So the first thing I like to try is plug in 2. If I plug in 2, I get 2 squared, which is 4, and 4 minus 4 is 0. If I plug in 2 to this, that becomes 4 plus 6 minus 10, which is also 0. So 0, 0, 0, 0 is an indeterminate form. To evaluate the limit, we're going to try something different. So we're going to try that factoring technique. And x squared minus 4, if you recognize, is a difference of squares. So we can rewrite that as x minus 2x plus 2. If I factor the bottom one, we're going to get, let's see, I think it's x plus 5, x minus 2. 5 times negative 2 is negative 10. And 5 minus 2 is 3, so that works out. Now the x minus 2's divide out, which is great. So now I'll be able to plug in x equals 2. So I have the limit of x plus 2 over x plus 5 as x approaches 2. Now when we plug in 2 to that, 2 plus 2 is 4. And 2 plus 5 is 7, so we get 4 sevenths. So that function, as x gets closer and closer to 2, is going to approach the value 4 sevenths. That's the goal for today. We're going to evaluate functions by factoring, evaluate limits by factoring. I'm going to do one more example where the factoring is a little bit trickier. Then we're going to evaluate limits by rationalizing. That's when we're multiplied by the conjugate and by getting a common denominator. So the last lesson was was very visual. This one's going to be more algebraic. So you can pause the video, copy this one down. But we're going to attack this one the same way as we attack the other ones. Let's see if we plug in 1, what happens. So if I plug 1 into this function, this becomes 1 minus 2 plus 1, which is 0. And if I plug 1 into this bottom one, I get 1 plus 3 minus 6 plus 2, which is also 0. And again, 0, 0 is that indeterminate form, so we need to do something different here. So let's see if we can factor it. And the top is going to factor to x minus 1 times x minus 1. Or x minus 1 squared. Now the bottom isn't really easy to factor. This is, I mean, it's got 4 terms, which was nothing that we're used to. But what I'm going to do here to factor it is I'm going to use synthetic division. The goal is to determine if this thing factors. And it doesn't really matter whether or not it factors. It matters, is x minus 1 going to be one of the factors? Because if x minus 1 is a factor, then we'll get something to cancel out, and then we can plug in 1 and not have to worry about getting 0. So in this situation, my question really is x minus 1 a factor? Of the x cubed thing. So can I rewrite this as x minus 1 times something else? And so synthetic division is going to be what I'm going to use. I'm going to check if x minus 1 is a factor of this polynomial. So if you remember the setup for synthetic division, 1 is the 0 that I'm looking for, this x minus 1 factor. So 1 goes in that top box, then I use my coefficients, which are 1, 3, 1, 3, negative 6, and 2. So if you remember the process from pre-calc, bring down that first number and then multiply 1 times 1 is 1. And then combine these, 3 and 1 make 4. And then multiply again, 1 times 4 is 4. Combine these, we're going to get negative 2. And then multiply 1 times negative 2 is negative 2. Combine these, we get 0. So getting 0, this is our remainder. So if you have a remainder of 0, that implies that x minus 1 is indeed a factor. So x minus 1 is a factor. The other factor is what you get from doing the division out, and when we did the division out, we get this right here. If you remember from pre-calc, the first term is a constant term, the second term is your linear term, or I'm reading from right to left. You go constant, linear, and then degree 2, and then if there's more stuff there, there'd be degree 3, degree 4, degree 5. So the other factor is 1x squared plus 4x minus 2. So this right here, this denominator, if you multiply it out, should get you back to, so if you multiply this out, it'll get you back to that top piece there. And that's how you can check to see if you did it right. But in this case, now that we have these x minus 1s dividing out, that leaves me now with the limit as x approaches 1 of x minus 1 over x squared plus 4x minus 2. And now if we plug in 1, I'm going to get 1 minus 1 over 1 plus 4 minus 2, which is 0 over 5 minus 2 is 3. 0 divided by 3 is 0. And so this is what the value of the limit is of this function as x approaches 1. So there's a little bit of synthetic division here, and so you can kind of jot that down up here. If it doesn't factor nicely, let's use synthetic division to see if the factor we're interested in is indeed a factor of the denominator that we're trying to factor. Okay. So, case 2. Solving analytically after an indeterminate form. Again, pause the video so you can copy it down. And this is what I'm going to call strategy 2. Strat for short. We're going to use something called using the conjugate. And I believe we did this with complex numbers back in pre-calc. And there was an example when we had our second homework assignment of the year, which was composition of functions, where an example like this showed up. But before we jump into the conjugate, again, plug in the limit. This is the limit as x approaches 0, so this becomes 0 over 0 plus 1 is 1, the square root of 1 is 1, minus 1 is still 0. So we get that 0, 0 case, we get that conjugate, indeterminate form. So now we got to try something different. And that's when we're going to multiply by the conjugate. So we're trying to find the limit of my function, which is x divided by the square root of x plus 1 minus 1 as x approaches 0. And if we plug in 0, we get 0, 0, so we don't know what the limit is approaching yet. Looking at a graph will probably give it away, but we're going to do this without a graph. So I'm going to multiply by the conjugate. So in this situation, the conjugate is going to be the square root of x plus 1, not minus 1. All right, we're doing kind of like a difference of squares here we're setting up. So multiply by the conjugate. And this seems random at first, but you're going to see how this allows us to actually evaluate the limit in a second. Now this thing in light blue is just 1, right? This would divide it with that, and we would get 1 over 1. So when you multiply by 1, that's okay. It doesn't change the value of our original function. Now, the reason why we're multiplying by the conjugate is because when we simplify this, we're going to get some nice things to cancel out on the denominator. So my square root of x plus 1 minus 1 and the square root of x plus 1 plus 1, I'm going to multiply that out first. When you multiply the square root of x plus 1 times the square root of x plus 1, you just get x plus 1. And then when you multiply the square root of x plus 1 times 1, you just get the square root of x plus 1. And then take the negative 1, distribute that. Negative 1 times the square root of x plus 1 is negative square root of x plus 1. And negative 1 times 1 is negative 1. The top doesn't have the square root part. I'm just going to leave alone. As I'm going through this, I'm recognizing that I can't plug 0 in. That's where I'm getting my 0, 0 case. So what I'm hoping that happens is at some point we're going to have an x over x cancel out. And then I'll be able to plug in 0. So at this point, recognize the carnage about to happen. These two terms cancel out. This plus 1 and that minus 1 is going to cancel out. So we really just have an x in the denominator. And then on the top, we have the square root of x plus 1 plus 1. And I left it factored because now I can recognize that this x is going to divide with that x. And that's going to be the key. That's going to allow me to now plug in 0 into my limit. So now I have just the square root of x plus 1 plus 1. And when I plug in 0, that becomes 0 plus 1. Take the square root of that and add 1 to that, which is 1 plus 1, also known as 2. Okay, so that's how we can evaluate a limit using the conjugate. If we were to graph this function on Desmos, as x approaches 0, this function is going to approach 2, but there's not going to actually be a point there, there's going to be a hole. So in a local to the left and to the right, we're going to approach that value. Who knows what the function is doing outside of that? I don't know. Okay. Here's another example. If you want to pause the video and try it yourself, you can. Otherwise, I'm going to go ahead. Sometimes in the numerator instead, so we have the square root in the numerator, and you might have issues with that, but let's plug in 3 first to see if there are any issues. 3 plus 6 is 9, and the square root of 9 is 3, so this becomes 3 minus 3, which is 0. And then on the bottom, we definitely have a 0. So it is an indeterminate case. In that case, I'm going to multiply by the conjugate again and see if we can get things to cancel out. Specifically, I want, because this is the limit as x approaches 3, I want an x minus 3 over x minus 3 somewhere to cancel out, and in which case then I'll be able to plug in 3 and not get a 0, 0 case. So that's my goal. Let's hope that happens. So I have 3 minus the square root of x plus 6 over x minus 3. So I'm going to multiply by the conjugate, which is 3 plus the square root of x plus 6. To multiply the top by that, I got to multiply the bottom by that, so I'm really just multiplying by 1, and I'm not changing the value of this function. Those parentheses are better to have them, not need them, than need them, not have them. Now the square root part I'm going to multiply out and see what I get. So 3 times 3 is 9. 3 times the square root of x plus 6 is 3 square root of x plus 6. And then the negative square root of x plus 6, I'm going to multiply that through. So negative square root of x plus 6 times 3 is negative 3 square root of x plus 6. And negative square root of x plus 6 times positive square root of x plus 6 is going to give me negative x plus 6. The square roots are going to cancel out. And this is all over the denominator. I'm going to leave the denominator alone like we did in the example above. Leave it factored. The hope is that something on top is going to allow me to cancel out this x minus 3 on the bottom. So now the reason why I multiply by the conjugate is because of all the carnage that's going to happen here. We got these are going to cancel out, which is nice. Big mistake that a lot of people make here is to recognize that this x plus 6 is in parentheses, and when we take the negative of that, that's going to make that a minus x minus 6. And when we do 9 minus 6, you're going to get a 3. So on the top I have a 3, and there's still that minus x here. On the bottom I have x minus 3 and 3 plus the square root of x plus 6. Now 3 minus x and x minus 3 don't cancel out quite, well, you'll see what's going to happen. On the side here, this is something that comes up in algebra, and it's a good thing to be aware of. 3 minus x is equivalent to negative x plus 3, which is equivalent to negative 1 times x plus 3. So if you just factor out the negative, you get that. So I can rewrite 3 minus x as negative x plus 3. Negative x minus 3. So all right. So yeah, if I factor the negative, then that's going to change that x to a positive and that that 3 to a negative because we took out the negative, which gives us negative x minus 3. So now I'm going to do some substitution here. This numerator becomes negative x minus 3. And the denominator is still x minus 3, and then 3 plus the square root of x plus 6. And we're taking the limit as x approaches 3. This x minus 3 and that x minus 3 are going to divide out. So now we're left with negative 1 over 3 plus the square root of x plus 6. And that's big because now that I got those x minus 3's to divide out like I was hoping, now I can actually plug in 3. So we get negative 1 over 3 plus the square root of 3 plus 6. So let's see, 3 plus 6 is 9. Ooh. The square root of 9 is 3, so it's going to be negative 1 over 3 plus 3. And 3 plus 3 is 6, so we get negative 1, 6. So those are two examples where we can use the multiply by the conjugate, do some algebra to simplify, and then once we do the simplification, then we can do the plugging in the limit and getting our value. Last case, call this case 3. Common denominator. So in this example, if you plug in negative 5, you're going to get 1/5 minus 1/5, which is 0, and negative 5 cubed is 125, so negative 125 plus 1. Negative 5 cubed is negative 125, negative 125 plus 125 is 0. So just do what we did before, get a common denominator, keep, change, flip. We're going to have to do a little factoring on the denominator, and then we'll be able to plug in negative 5 and not have any issues. So the common denominator is going to be 5x, so I'm going to multiply the top and bottom of this piece by x and the top and bottom of this piece by 5. So I'm trying to find the limit as x approaches negative 5 of this function, which I can rewrite as x plus 5 divided by 5x, all divided by x cubed plus 125. I'm going to do the keep, change, flip step, so So you can think of this as x cubed plus 125 over 1, and then keep, change, flip. This is equivalent to the limit as x approaches negative 5 of x plus 5 over 5x change division multiplication, and then flip this, so it's going to be 1 over x cubed plus 125. And so the problem that we're facing right now is that nothing actually canceled out. I didn't get an x plus 5 on the top to cancel out with an x plus 5 on the bottom. So I still can't plug in -5 in. I'm still going to get 0 or 0. But if you recognize x cubed plus 125, that's a difference. This thing, that's a sum of cubes. So if you remember from a little while ago, we talked about sum and differences of cubes. Here's where we need it. So if you have something in the form of a cubed plus b cubed, or a cubed minus b cubed, those will always factor to what I'm about to show you. So one thing when I set this up is I recognize that this is kind of the pattern for the two factors, and then to find out where the pluses and minuses go. I don't know if you remember, I used the acronym SOAP. Which stands for same, opposite, and then always positive. So the same means use the same sign. So if this is a sum of cubes, the first one's going to be the same, the next sign is going to be the opposite, and the last one is always positive. So even if it's a difference of cubes, we can still use SOAP. So if it's a difference, then it's going to be the same, opposite, always positive. So in our x cubed minus 125 situation, you have to recognize that 125 is equivalent to 5 cubed. So that's going to look like this one up here. So that's going to become a plus b, or in this case x plus 5. And then x squared, x times 5 is 5x, and then b squared or 5 squared is 25. And same, opposite, always positive. So I'm going to use this factored version, right, because this is just x cubed plus 125 down here. And what's great, if you're noticing, is that there's going to be some x plus 5s that are going to cancel out. So on the top I have that one factor, on the bottom I have this 5x factor, and the x cubed plus 125 factors to x plus 5 times x squared minus 5x plus 25. And so now I have 3 factors on the bottom, but it's all factored out. This x plus 5 up here is going to divide out with that x plus 5 down there. And now that those x plus 5 factors are gone, we're actually going to be allowed to plug in -5. So if I plug in -5, I'm going to get 1 over 5 times -5 times -5 squared minus 5 times -5 plus 25. So this is me just plugging -5 in for x. So that's going to give me 1 over 5 times -5 is -25. And then here, -5 squared is positive 25. -5 times -5 is another positive 25. And there's just another 25 there. So this is 1 over -25 times 75, which is -1 over 1875, I think. That's it. So we're going to stop there. The main point of this lesson is just to, again, it's like a little bit of an algebra review, but we're using these algebra tools to evaluate limits. And the goal is to, whenever we get the 0 over 0 case, we can try to do some algebra and see if those zeros are going to divide out. And in that case, what's happening there is there's going to be a hole. That actually, just because there's a hole there doesn't mean the limit doesn't exist there. I think actually before we end this, there is one more example, and it's going to take you longer to actually write down the question than it is to answer it. In this limit, and again, pause the video so you can write it down. In this limit, I always tell you to plug in 3 first, and when you plug in 3, you get 1/3 plus 1/3, which is actually not 0. 3 cubed is 27, so you get 23 divided by 0 case. This is not an indeterminate form. So it's not that we can't evaluate, it's not that we need more work. It's not that we can't determine what's going on. And actually, it turns out that if you have a number of 0, there is going to be no limit. The limit does not exist in these situations. So just last thing to copy down is if you plug in that value into your function and it's undefined, but it's not an indeterminate form, so it's not a 0, 0 case. Then nothing is going to divide out. And by nothing, like the x minus 3 factor is not going to divide out. So the limit does not exist, as Lindsay Lohan once said. Anyways, okay, so now you guys have some practice problems to do for homework. Thank you for watching the video. Again, consider following the channel. Having a lot of followers helps. It turns out that only 10% of you are actually following, which is a small percentage of the people who are actually watching the video. So make sure to ring the bell for notifications if you would like that. And please leave a message in the comments.